Tell me about a time you had to make a decision independently. Introduction. This is a common behavioral interview question for software developers, backend developers, full-stack developers, senior developers, and team leads. Interviewers ask this question to understand: whether you can make good decisions without constant supervision, how you handle ambiguity, how you evaluate risks and trade-offs, how you use available information, whether you know when to proceed and when to escalate, how you communicate decisions afterward, whether you take ownership of the outcome. This question is especially important for check Java developers, backend developers, Spring Boot developers, full-stack developers, senior software developers, team leads, agile teams, production support teams. The best way to answer this question is by using the STAR method. STAR means S, situation, explain the background. T, task, explain your responsibility. A, action, explain what you personally did. R, result, explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand how you analyzed the situation, made the decision, managed risk, and communicated the result. Question: tell me about a time you had to make a decision independently. Example 1. Choosing a safe API error handling approach situation. In one sprint, I was working on a Spring Boot API for customer profile updates. The requirement explained the happy path clearly, but it did not define every error scenario. The product owner was unavailable for part of the day, and QA needed the API behavior finalized so testing could continue. I needed to make an independent decision about how the API should handle validation errors, without blocking the story completely. Action. I first reviewed the existing API standards in our application. I checked how similar APIs handled missing required fields, invalid field format, unauthorized access, forbidden access, record not found, duplicate request, unexpected system error. Then, I looked at our standard error response format. I decided to follow the existing team pattern instead of inventing a new response style. My decision was: quick, return 400 bad request for validation errors. Click, include field-level validation details. Click, return a user-friendly message. Click, include an internal error code. Click, include correlation ID for troubleshooting. Click, avoid exposing internal exception details. I also added examples to the story notes so QA could test the behavior. When the product owner became available, I explained the decision and confirmed that it matched the user experience expectation. Result: QA was able to continue testing without waiting. The API behavior stayed consistent with the rest of the system. The product owner accepted the approach because it was aligned with existing standards and did not create unexpected user behavior. Why this answer works? This answer is strong because it shows independent decision-making, use of existing standards, risk reduction, API design judgment, QA support, communication after decision. Example 2. Deciding to add pagination to a search API situation. In one project, I was implementing a customer search API. The initial requirement said users should be able to search customers and view matching results. It did not clearly mention pagination, but the customer table had a large number of records. Task: I needed to decide whether to return all matching results or add pagination from the beginning. Action: I reviewed the expected data volume and how similar APIs worked in the system. I considered 2 options. Option 1 was to return all matching records. This would be simpler initially, but it had risks. Slow response time, large payload size, browser performance issues, database load, timeout risk, poor scalability. Option 2 was to add pagination. This required slightly more implementation effort, but it provided faster responses, predictable payload size, better user experience, safer database usage, easier future scaling. Since the system already had pagination patterns, I independently decided to implement pagination with a default page size and maximum page size. I documented the decision in the API notes and added sample request and response examples. Then I informed the product owner, QA, and front-end developer. Result: the API performed better with large data. Front-end integration was clear because the response included pagination metadata. The product owner agreed with the decision because it protected user experience and production performance. Why this answer works? This answer is good because it shows: check technical judgment, check scalability thinking, check performance awareness, check independent trade-off analysis, check documentation, check stakeholder communication. Example 3. Deciding to use mock responses for a blocked integration situation. In one sprint, our Spring Boot service depended on a downstream API owned by another internal team. The downstream API contract was available, but the QA environment endpoint was not ready yet. Waiting for the endpoint would have blocked our development work. Task: I needed to decide how to keep progress moving while the external dependency was unavailable. Action: I first confirmed that the API contract was stable. I reviewed endpoint path, request payload, response payload, required headers, authentication method, success response, error responses, timeout behavior. Then I decided to create mock responses based on the confirmed contract. This allowed us to continue client implementation, request mapping, response mapping, timeout handling, error handling, unit testing, QA test preparation. I was careful not to treat mock testing as final integration testing. I clearly documented that real end-to-end testing still depended on the downstream environment. I shared the plan with the Scrum Master, product owner, QA, and developers. Result: development continued without waiting for the downstream team. When the real endpoint became available, integration testing was completed quickly because most of the client logic was already prepared. The decision helped reduce schedule impact while still keeping the risk visible. Why this answer works? This answer is strong because it shows independent problem solving, dependency management, practical mitigation, clear communication, risk transparency, delivery ownership. Example 4. Deciding not to merge a risky pull request situation. In one sprint, I completed a backend change close to the end of the sprint. The code worked functionally, but during my final review, I noticed that the change duplicated validation logic already used in another service. The deadline was close, and I could have merged it to finish the story. Task: I needed to decide independently whether to merge the working code or delay slightly to refactor it properly. Action: I evaluated the risk of merging the code as is. The risks included duplicate validation logic, inconsistent behavior in future changes, more maintenance effort, higher chance of regression, harder testing later. I decided not to merge immediately. Instead, I made a focused refactor. I extracted common validation logic into a shared validator while keeping service-specific rules separate. I added unit tests for cert new feature validation, cert existing validation behavior, cert invalid input, cert valid input, cert edge cases. I updated the pull request description to explain the decision and the impact. Then, I asked for re-review. Result: the story took slightly longer, but the final implementation was cleaner and safer. The reviewer appreciated that I avoided adding unnecessary technical debt. The shared validator made future validation changes easier. Why this answer works? This answer is good because it shows: check independent quality decision, check technical debt awareness, check maintainability thinking, check responsible deadline trade-off, check testing discipline. Example 5. Deciding to escalate a production alert situation. In one production support rotation, I noticed an increase in API error rates from the monitoring dashboard. The alert was not yet marked as critical, and there were only a few support reports. However, the error rate was higher than normal for that endpoint. Task. I needed to decide whether to wait for more reports or escalate the issue early. Action. I reviewed the available information. I checked. Error rate trend. Affected endpoint. Recent deployments. Logs. Correlation IDs. Affected users. Response status codes. Downstream service health. I noticed that the error started shortly after a recent deployment. Even though the impact was still limited, I decided to raise it early in the production support channel. I shared. Check. What I observed, when it started, which endpoint was affected, possible relation to recent deployment, logs and sample correlation IDs, suggested next steps. I also started checking whether a rollback or hotfix might be needed. Result. The team investigated early and found a missed edge case in the new API logic. Because we escalated before the issue became widespread, the fix was applied quickly. The incident impact stayed limited. Why this answer works? This answer is strong because it shows, quote, independent judgment under pressure, production monitoring, early escalation, evidence-based decision, incident ownership, user impact prevention. Example 6. Deciding to split a complex story situation. In one sprint, I was assigned a report feature that initially looked like a simple API and UI display. After reviewing the requirement, I found hidden complexity around calculations, date filtering, time zone handling, data volume, and export behavior. Task. I needed to decide how to handle the story because delivering everything in one sprint would create quality and testing risk. Action. I analyzed the work and separated the must-have functionality from later enhancements. The full scope included backend calculation API, date range filtering, business time zone handling, large data volume, QA test data, UI display, export functionality, advanced filters. I decided to recommend splitting the story instead of trying to complete everything at once. The first story would include check. Backend calculation API. Check. Basic UI display. Check. Date range support. Check. QA validation with sample data. The later story would include export functionality. Check. Advanced filters. Check. Additional formatting. I documented the reasoning and brought the recommendation to the product owner and Scrum Master. Result. The product owner agreed to split the work. The first version was delivered with better quality. The remaining features were planned properly instead of being rushed. Why this answer works? This answer is good because it shows independent analysis, scope judgment, product thinking, risk management, stakeholder communication, quality first delivery. Example 7. Deciding to add extra regression tests situation. In one project, I changed shared validation logic used by multiple APIs. My assigned task only required testing the new feature. However, I noticed that the shared validator was also used by older APIs. Task. I needed to decide whether to spend extra time adding regression tests for the older flows. Action. I reviewed the usages of the shared validator and found several existing APIs that depended on similar validation behavior. I considered the risk. If I only tested the new feature, an older API could regress without being noticed until QA or production. I decided to add extra regression tests. The tests covered new API behavior, older API behavior, required fields, optional fields, invalid input, valid input, error response format, backward compatibility. I also added a note in the pull request asking reviewers to pay attention to shared validation behavior. Then, I communicated the impacted areas to QA so they could focus testing properly. Result. The extra tests caught one behavior difference before release. We fixed it before production. The decision helped prevent a regression and improved confidence in the shared change. Why this answer works? This answer is strong because it shows key independent risk detection, key regression testing, key shared code awareness, QA communication, key prevention mindset, key quality ownership. Example 8. deciding to improve logging during a bug fix situation. In one production support task, I was fixing an API issue where users sometimes received a generic error. The immediate bug was clear, but logs did not provide enough detail to troubleshoot similar issues quickly in the future. Task. My assigned task was only to fix the bug, but I needed to decide whether to improve logging as part of the fix. Action. I first fixed the root cause of the bug. Then I reviewed the logging around the affected flow. I noticed that logs did not consistently include correlation ID, endpoint name, safe business identifier, validation failure reason, downstream response status, processing step, error category. I decided to improve logging because it was a low-risk change that would help future troubleshooting. I made sure not to log sensitive information. I added structured, safe logs and updated the troubleshooting notes with examples of how to search by correlation ID. I also mentioned the logging change in the pull request, so reviewers could validate it. Result: the immediate issue was fixed. Future investigation became easier because logs contained better context. Support teams could provide more useful information when escalating issues. Why this answer works. This answer is good because it shows independent improvement decision. Check. Production support thinking. Check. Observability. Check. Security awareness. Check. Beyond the ticket ownership. Check. Practical judgment. Best short answer version. If you need a short interview answer, you can say, in one project, I was implementing a customer search API. The requirement said users should be able to search and view matching customers, but it did not clearly mention pagination. Since the customer table had a large number of records, I had to decide whether to return all results or add pagination from the beginning. I reviewed the expected data volume and existing API patterns. Returning all results would be simpler initially, but it could create slow response times, large payloads, database load, browser performance issues, and timeout risk. I independently decided to implement pagination with a default page size and maximum page size because it was consistent with our existing API standards and safer for production. I documented the decision, added sample request and response examples, and informed the product owner, QA, and front-end developer. As a result, the API performed better with large data. Front-end integration was clear, and the product owner agreed with the decision because it protected user experience and scalability. Common mistakes to avoid. 1. Making a decision without evidence. Bad answer. I just chose the approach I liked. Better answer. I reviewed existing standards, data volume, risks, and impact before making the decision. 2. Not communicating the decision. Bad answer. I made the decision and implemented it. Better answer. I documented the decision and informed the product owner, QA, and front-end developer. 3. Making a decision that should have been escalated. Bad answer. I changed the business requirement myself. Better answer. I made a technical decision within my responsibility and confirmed business behavior afterward. 4. Ignoring risk. Bad answer. I picked the fastest option. Better answer. I considered speed, quality, maintainability, performance, and user impact. 5. No result. Bad answer. The decision worked. Better answer. The API stayed consistent, QA continued testing, and the feature was delivered safely. Best practices for answering this question. CUC. Use the STAR method. CUC. Choose a decision within your responsibility. CUC. Explain why guidance was limited. CUC. Show how you gathered information. CUC. Compare options. CUC. Explain risks and trade-offs. CUC. Make a clear decision. CUC. Communicate afterward. CUC. Show the result. What interviewers are looking for. Interviewers want to see whether you can work independently, use good judgment, handle ambiguity, make decisions based on evidence, balance speed and quality, know when to escalate, communicate decisions clearly, take ownership of outcomes. For senior roles, they also want to see technical leadership, risk assessment, architecture judgment, production awareness, stakeholder communication, prioritization, decision-making under uncertainty. Strong words to use in your answer. You can use words like evaluated, compared, decided, assessed risk, used existing standards, documented, communicated, mitigated, aligned, confirmed, protected quality, reduced risk, improved reliability. Example: I made the decision independently by reviewing existing standards, comparing the risks of each option, choosing the safer approach, documenting the reasoning, and communicating it to the team afterward. Good independent decision topics you can use. Depending on your experience, you can talk about choosing API error handling approach, adding pagination to an API, using mock responses for blocked integration, not merging risky code, escalating a production alert, splitting a complex story, adding extra regression tests, improving logging during a bug fix, choosing caching for read-heavy API, validation for edge cases, using existing team standard instead of new pattern, delaying deployment for safety, adding monitoring after release, choosing synchronous versus asynchronous flow, isolating risky change behind feature flag. Final summary. Tell me about a time you had to make a decision independently. Is an important interview question because software developers often face situations where they need to use judgment without waiting for detailed instructions. The best answer should include: what decision you had to make, why you had to decide independently, what information you reviewed, what options you considered, what risks you evaluated, what decision you made, how you communicated it. Good examples include mock API error handling decision, pagination decision, mock integration decision, code quality decision, production alert escalation, story splitting decision, regression testing decision, logging improvement decision. The strongest answers show independent judgment, evidence-based thinking, risk awareness, communication, and ownership of the outcome.